see that. It's also on my screen, but I don't know if that's easier to see. Up to you guys how you want to take notes. I'm happy if you want to type while I'm talking. I'm happy if you just want to sit and listen. I'm happy if you want to jot things down. What I am writing on here, I will scan and put on my Google site. Same thing with the video that I'm making right now. Okay. So first thing that we talked about was looking at the structure of atoms. Are we okay with the structure of atoms? Okay, so you don't need me to run through it. Okay, so the next thing then that I definitely want to give you guys notes on, I'm just going to steal your piece of paper to talk about it so I can show you what I mean, is I want to talk about how we classify different types of matter into one of three categories. So the first category that we're thinking about is element. Element is just talking about the pure atoms, so atoms by themselves, like this. Cool. The next thing was compounds. So, I'm trying to think what's this way. So compounds and mixtures, and this actually has a couple of different types of mixtures, are basically, if I was to do a classification key, if I'm trying to identify what is the substance. So let's say that's my question. First thing I have to ask myself, is it only made up of one type of element? Or sorry, atom. It's the other way we can think about it. Just watching our time because I need to make sure you guys can clean up the beakers. So if your answer is yes, then that's going to fall into the category of element. It's a pure substance. Cool. If the answer is no, then it could be one of two things. Either it is going to be a mixture or it's going to be a compound. And when we think about our types of investigation, I am actually using one of our skill sets, and that is classifying and identifying. So answer is no, it's not made of one thing. So what I need to now ask myself, if there's more than one thing, is are they chemically bonded together? Is our next question. And I'll talk about what chemical bonds are too. So when we are talking about chemical bonds, we are talking about, I think how I would describe it. There are two main ones that we're thinking about for chemical bonds. There's a third one that would technically count, but then it kind of complicates things if it's an element or if it's a compound. But anyway, when we're thinking about chemical bonds, we are thinking about if they are covalent, ionic, or metallic. And I'm going to put a little asterisk around metallic, and I'll explain why at the very end. So, yes or no? If the answer is yes, then you are dealing with a compound. If the answer is no, then you are dealing with a mixture. Now, when it comes to mixtures, we can have multiple different types of mixtures. The first type of mixture we can have is a mixture of elements. So say, for example, I have hydrogen and I have oxygen. That is a mixture of elements. I could also have a mixture of compounds, which could be, for example, I have nitrogen and I have water. So nitrogen is an element, and then, mixture of compounds. Ammonia. So both of these are compounds. Or I can have both. Say, for example, I have hydrogen as the element and I have water. We good? Okay, so that was this kind of worksheets over here. So you were just looking at it visually and trying to figure out what label you're going to give it. So that was that one. These two were very similar in that sense. And the only difference is now you're justifying why. And you can see here that when we were talking about things that are chemically bonded, you see how they were kind of grouped together with the bubbles. So that was that one. All right. The next thing that is important then to think about is going to be this big sheet here. So this one is tying to this idea of what are chemical bonds. So this has a little mind map. It's really worthwhile to do this mind map and to do it well because it's going to help you downstream when we're talking about graphene. So like I mentioned, there are ionic bonds. Go away. We have ionic bonds, and we have covalent bonds, and we have metallic bonds. So if you remember, that fell over here for the chemical bonds with the yes, no here. The other type of bond we have, and I shouldn't really call them a bond, the better word for it is force. I can't really think of a good way to decide when to use the word force and when to use the word bond. I guess bonds, we're typically thinking about an interaction between atoms, whereas forces, you're thinking of like an interaction between molecules is kind of the best way I can distinguish the two. So when we're thinking about forces, we have van der Waals forces, and then we have hydrogen bonding as one of the types of van der Waals forces. I will talk about these three first, and then I'll mention the van der Waals, because then it leads into why I gave you these assessment questions. So let's move on to the next page. So the first one we'll do is the ionic bonds, because I think that one's probably the easiest, and that's probably the one you guys have seen before. So ionic. So when you guys are looking at atomic structure, let's say, for example, sodium, you know that the sodium atom has 11 protons. We're not worried about the neutrons because they don't contribute to the charge. And the other thing we have are the electrons, also 11. So if I was to fill out my electron configuration, there'd be 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell. So now I'm at 10, and then 1 in the last shell. So that makes 11. Sorry, just trying to refocus it. Does that make sense so far? Oh dear, come on, focus. Right, let's do another example because then I can use it for ionic bonds. Chlorine. Chlorine has the atomic number 17, so that's 17 protons. In its first shell, it's going to have 2. In its second shell, it's going to have 8. That brings me up to 10 again. And then in the third shell, oh my god, I'm so bad at this today, has 1, 2, 3, 4, 5, 6, 7. We good so far? All right. When we are talking about atoms, we have to think about stability. And atoms are most stable when they have a full shell. If it has an incomplete shell, it is less stable. So all the various chemical reactions that things do are in order to make some sort of combination to become stable. So the first one, like I said, is our ionic bonds. So when I look at sodium, for example, it has 1 electron in its valence shell. So it can either gain 7 more or it can lose 1. The easier option is to lose 1. So if it lost 1 of these electrons, then we now have 10 electrons. And if I have negative 10 plus positive 11, I'm going to get positive 1 left over. So what I've made is the sodium ion. Now, I cannot create or destroy matter. This electron needs to go somewhere. So it's going to buddy up with some other element and transfer those electrons. Chlorine is a good example. Sodium chloride is table salt. In this case, I have 2, 4, 6, 7 electrons. So again, for it to have its full shell, easiest way, gain 1, which is very convenient because this guy lost 1. And again, when I check the numbers, we have negative 18 now plus the positive 17, so now I have negative 1. So that's how we're getting there. All right. When we talk about the ionic bond isn't the transfer of the electron, it's the electrostatic attraction between our ions. So this has now become a cation. It is now positive. This is now an anion, and this is now negative. And feel free to stop me if at any point. Okay? So what we know is that positive and negatives attract, opposites attract, and so these two ions will be drawn to each other. And so that electrostatic attraction is what causes the ionic bond. Okay? The next one we have is our covalent bonds. So I'm just trying to keep to a color code. Now, covalent bonds, the difference in this case, instead of transferring electrons, it's going to share electrons to fill its shell. So if we think about the example of H2O, so that has hydrogen. The little 2 on the bottom means 2 hydrogens, and then you have an oxygen. So let's draw that out. So if I was thinking about oxygen, it would be positive 16 in the nucleus. It would have 2 electrons in the outside. 1, 2, 3, 4, 5, 6, 7, 8. So that's 10. And then in this last shell, it will have 6. So 1, 2, 3, 4, 5, 6. Probably actually should have made fewer. Space them differently. All right. So it is not stable. Now what it's going to do is it's going to share electrons with hydrogen. So if I have a hydrogen atom, that's a positive 1. Whoopsie. Hydrogen. 1 proton. And it only has 1 electron in its valence shell. Should actually probably have drawn that a little closer. So what's going to happen is these 2 electron shells are going to overlap. So one of these electrons is going to be coming from the hydrogen, and the other electron is going to be coming from the oxygen. So this only has 1 shell. So for the hydrogen atom to be stable, it just needs 2 electrons. So it's sharing it with the oxygen. And now oxygen has gained another electron to help fill its shell. So that's what's happening when it's doing that. And then same thing with the second hydrogen. Plus 1. So that's the second hydrogen. So this one is our oxygen, and then these 2 are our hydrogens. So that's what we're referring to when we say covalent bond. Cool. Metallic bond I won't go into huge detail with because we do cover that in level 2 and you don't need it for this assessment. The thing we have to remember about metals though is that you can have metals of different kind of stuff. So you can have pure metals, which will just be the element if I was classifying it. So for example, if I had, just trying to think of, there we go, I'm watching the time too. So for example, if I just had silver, Ag, that would just be pure silver, nothing else. What we can do with metals as well is we can mix metals together, because when we mix them together, they then kind of get different properties. So you could have a mixture of metals. Which is known as an alloy. So for example, with my ring that I'm wearing right now, there's a little number on it that says 92.5. So it's 92.5% silver, and I think the remaining bit of it is copper. And the reason why you mix in a little bit of copper is just to make it a little bit tougher. So like an alloy of silver and copper. So in this case, both of these will have metallic bonds, but this is going to be classified as an element, and this is going to be classified as a mixture. So that's why I kind of put a little asterisk next to it, because technically a metallic bond is a chemical bond, but it's not the only way to kind of think about if it's a compound. So the thing to keep in mind is when we make classification keys, they're not always going to be perfect. And that's why it's important to understand the context. Are we okay with that? Okay. The last thing I just want to kind of go through is, just trying to find more colors, are the van der Waals. So what you can have in this case is you can have things that are molecules like water, like that, And we know that in water, these two bonds here are the covalent bonds. So I'm just going to put these into green. So within the molecule, we have a covalent bond. Now, these water molecules can interact with each other, and they can have a force. Actually, I should put the dots next to the hydrogen. There's a force here. And that force of attraction kind of holds it together, and that's what we're talking about when we talk about van der Waals. So these here are known as molecules because they're small structures. Okay? So I won't dive into more detail with that. You guys can go down that rabbit hole, and that's what the mind map's for. But the reason why I need to talk about this stuff first is because we need to think about how we classify our solids into different categories. The reason why we need to think about how we classify them is because when you guys do graphene as your essay, two things. First off, actually no, one thing. Graphene is one of these types of solids. So we need to understand the other types of solids to be able to know graphene structure. The other thing is I wanted to talk in a general overview point about bonding and atomic structure because we can justify the properties graphene has based off of its interactions. And graphene has both covalent bonds and intermolecular forces. So the way to kind of think about when we have these different categories is we have to ask ourselves what is making up that solid. So if I just have the pure element, and this element on the periodic table is a metal, and I should have printed off some periodic tables for you guys, but when you look at a periodic table, there's on the left-hand side is metals, on the right-hand side is nonmetals. So if I have something that is just a metal, just an element and the element is a metal, then that is going to be metal as the classification. Metals are made up of atoms, and the bonds that hold them together are metallic bonds. If I look and I see that things are a mixture, I should say mixture, because mixture is classification. If I look at it and I notice that there are two or more different types of atoms, then I ask myself, are those atoms metals, or are those atoms nonmetals, or are they a mixture of both? In this case, when I look at the periodic table, phosphorus and chlorine are both nonmetals. So if I see two nonmetals, then it's some sort of covalent type structure. Either it's covalent molecular or it's covalent network. I won't go into too much detail. Maybe I'll do that in the next lesson, talking about the difference between these two. So that's kind of that idea. If I have a metal and a non-metal, then that classifies it as ionic because they will transfer those electrons. So that is made up of ions, which is what those guys are called, cation, anion, and they have ionic bonds. Are we okay so far? All right. So when I'm trying to think about the difference between covalent molecular and covalent network, the covalent molecular are these guys here. They're very simple, very small, and they will have certain properties. So covalent molecular are made up of molecules, which is what that is, and they have the weak intermolecular forces or van der Waals bonds to hold them together. Covalent networks are large 3D structures, and they're far more complex. When it comes to this one here, there's only 3 types that they use for the structure and bonding assessment. You're not doing that one, but the graphene ties into that. So there is silicon dioxide, which is that guy. There is carbon-based stuff. So the 2 carbon ones that can give you is diamond and graphite. And graphite relates to graphene, which is what your essay is going to be on for the internal. So that's how you kind of classify in those 3. If you have a covalent network, they are made up of atoms, and what holds them together is covalent bonds. So that's kind of that work there. I do have videos explaining this for my level 2 chem class that I have linked onto the Google site if you guys want to watch those. But that's why I gave you that stuff. Anna, what was your question that you had on this sheet? Oh, the S? The G? Yeah. That's not a G, that's an 8. It's an 8. So it just means 8 sulfurs. So 8 sulfur atoms. But okay. But I will point out this because it's an important thing to think about. You see how there's these little annotations here on the side? That gives you the state of the matter. So S is solid, L is liquid, G is gas, AQ is aqueous. That's dissolved into water or dissolved into something, usually water. Cool. All right. Any questions? No? All right. So what I have to ask you guys is, so I can see, do you guys want some more time to work on lesson 1 and 2, or actually more so lesson 2, and digest what I've talked about today? Or do you guys want to move on to something else tomorrow? You're ready to move on? Might as well, yeah, because it helps if you guys are doing the same thing. All right, cool. I will find something else for you guys to do next lesson. Cool. All right. And Armando, you're just going to have to catch up on the weekend.